Because optical fibers do not radiate energy, it is impossible to use conventional RF signal detection equipment to locate a purely dielectric fiber optic cable. Even in cases where the cable is armored or contains metallic messengers, national electric codes dictate that these components be bonded to ground at points where metal parts are exposed, making their use as locate conductors impractical. Other conventional techniques of cable identification include the use of an OTDR or fiber identifier. The fiber identifier approach is common, but can only be used once the cable jacket has been removed and the fibers have been accessed. Another technique used is the introduction of microlosses in the target cable by a bending clamp or freezing. Physical cable bending results in a macro bend, while the freeze method introduces a micro bend to the cable's internal fibers, either of which can be seen on the OTDR if conditions are right. However, many fiber optic cable structures are rigid, and all cables contain buffering to protect the fibers from the effects of bending. As a result, slight bends may not be visible to the OTDR, but if bending becomes too severe, the cable may suddenly kink and damage the internal fibers. Fortunately, there is a simple solution in the form of the FiberPro Model CI4000 Acoustic Fiber Cable Identifier, or AFSID. Developed for practical field applications and the requirements of large telecom customers, the AFSID uses optical interferometry for cable identification. This technique transforms the cable into an extremely sensitive audio detection device. The patent-pending innovation of the FiberPro AFSID system provides a user-friendly, non-invasive way of fiber optic cable identification that does not require cutting, bending, or freezing of the cable. This instrument is an extremely useful outside plant tool that greatly reduces the time and expense of cable management, maintenance, and repair of fiber optic networks. With the AFSID, the user can easily find a target optical cable by gently tapping on it. The AFSID system detects the tapping and provides an audio output as well as a visual display for use in noisy environments. The instrument is terminated to a pair of spare or dark fibers in the target cable, and the fibers connected at the remote end of the cable span with a jumper to form a loopback. Gentle tapping applied to the cable at almost any point along the span can easily be detected by the